All right, so first thing we have here is a central angle. An angle whose vertex is the center of the circle and whose sides are radii of the circle. So CA and CB, those two segments are both a radius of the circle because they're from the center touching a point on the circle. And that angle, right, angle ACB would be our central angle. So now central angles and the arc they made, right? Central angles and the arc that's made, okay, have a very strong relationship with one another. Okay. Before we get to that though, we're going to describe all the rest of these points. So we have an arc, all the points between and including any 2 points on the circle. So an arc is equivalent to a segment, right? A segment though is on a straight line, okay? It's part of a straight line where you have your 2 endpoints, all the points in between. An arc includes all the points on the circle, including the 2 endpoints. Okay. And just like we would name a segment with putting a segment on top of it, we can name our arc by putting an arc, okay? An arc on top of the 2 endpoints. So this red arc is arc DE. You actually don't need to write both parts. You can just write it like that, arc DE or arc DE without putting the arc on top. Okay. Arcs have 2 measures. You may go back. Okay. Oh.
Yeah.
So arcs have 2 measures. Okay, there's 2 ways you can measure an arc. All right, you can measure it by degree. Okay. You can measure it by degree, which is the degree measure of an arc, the same as the degree measure of the central angle that intercepts the arc. So as I mentioned on that first slide, there's a very strong relationship between the central angle and the arc that's made. They are equivalent. All right, and it makes sense when you're talking about degrees. A circle all the way around is 360 degrees. Same way an angle, okay, that goes all the way around is 360 degrees. So a lot of times when we could measure an arc by the angle that makes it up, the other measurement you could have, sorry, I guess we'll talk about the degree first. There is another way you can measure it. We'll talk about that in a second. We're going to be focusing more on degrees throughout this unit anyway, but it is good to know the other method of measurement, which is a distance measurement, kind of like using a ruler, but a curved ruler. Right, so angle ABC is a central angle. Right, it has a measure of 115 degrees. Arc AC is also equal to 115 degrees. Okay, so central angles and the arcs that they intercept are equivalent. So the other way that we can measure is by length. Right, the length of an arc is the distance between the two endpoints along the circle. Right, and we could measure this in, like I said, if we kind of curved a ruler around, or we took a piece of string and put it along those two endpoints and then straightened the string out and measured it, we could figure that out. The problem with circles, it's not a problem, but circles, the length that you go all the way around an entire circle is rarely an even whole number, okay? The circumference is rarely a whole number, all right? And that's because typically we talk about circles having whole numbered radius or a whole numbered diameter. But in order to get your circumference, you're doing the diameter times pi, 3.1415. It's that decimal that goes on forever without repetition, which means that your circumference is almost always going to be a decimal that's going on forever without repetition. Okay, so while the distance around a circle can be hard to think about in finite terms, all right, you can still find the distance between 2 points. All right, so if we wanted to find the measure of some of these angles, right, because we know that there's, these go pretty fast here, but well, we can use some different properties of circles in order to do this. There's not one shown here, but let's say we're trying to find that arc measure x. Well, that's equivalent to the angle measure, so it's 140 degrees. Goes the other direction too. If you know the arc degree measure, then the angle measure, if it's a central angle, will be equal. 2 degrees. Another property, if you have a segment that goes through the center, right, that makes it the diameter of the circle, right? Well, that makes 180 degrees angle because half of a circle is 180 degrees. So if we know that from here to there is 180 degrees, if we take 120 away from that, that leaves us with this angle, which is 60 degrees. And lastly, a full circle is 360 degrees, or an angle that starts here and finishes here would be a 360 degree angle. So to find that angle is in the bottom right. You just have to subtract all those other angles from 360. Let's see, 360 minus 103 minus 43 minus 8 minus 47. 59 degrees. I think central angles in the arcs are fairly straightforward. When you start incorporating some of the other angles and some of the other different things that can be constructed within the circle, where it gets a little more difficult. So minor arcs, so there's a couple different arcs that we can define within a circle. Minor arcs are the ones we've been working with. They're the ones that are between 0 and 180 degrees. A major arc is an arc that is greater than 180 degrees. And the reason why we need to differentiate between the two is because I could put 2 points on a circle. Okay. And there are 2 arcs I can make from those 2 points. I can make this green arc. I can make this blue arc. And we have to be able to differentiate between the two. The minor arc is the one, the green one. It's less than 180. Thank you. The major arc is the blue one. So we can't just write arc A, B for both of them. Now, there's a way that we differentiate between the two. Okay. The last one you talk about is a semicircle. That's the one that's 180 degrees. Okay. 180 degree arc is a semicircle because it's half of a circle. All right, so the way we name minor arcs is how we've been naming them, where you just name your 2 points. Okay, so if I say arc FI is the red arc. So we name our minor arc. But the way we name a major arc, I want to do points F and I again. It's named by the 2 endpoints and a point on the arc between the endpoints. So if I just say arc FI, I'm talking about this arc. If I want to talk about major arc FI, right? I have to take one point that's in between the two. So I can either use K, J, or G and write it in between. I'm going to use J. Right? So in order to name a major arc, you have to use 3 points. That way, you know what direction the arc is going. Okay, by talking about a point that's in between. The way you name your semicircle is the same as the major arcs because there's 2 ways that you could go with that semicircle endpoints. So you have to use that 3rd point in the middle. So if I wanted to talk about this semicircle, I would need to use H or I in the middle. So say arc F, H, G. That way I know I'm talking about the one that goes along the top. This is as much for you guys so that when you need to answer, you're answering correctly, but also if you're posed a question, you know which arc that we're talking about. An inscribed angle. An angle whose vertex is on the circle and whose sides intersect the circle. So this is angle ABC. And it's an inscribed angle. The measure of an inscribed angle is half the measure of its intercepted arc. Right? So this angle, angle ABC, okay, this intercepts with the circle at points A and C, giving us arc AC. this angle is always half the measure of the arc's angle. So arc AC is going to equal 76 degrees if angle ABC equals 38. I think you guys can probably see where this is going. There's also, because there's a relationship with the arc, we can also have a relationship with central angle as well. Just a few more slides. If an inscribed angle intercepts a diameter, then the inscribed angle is a right angle. This makes sense, okay? If you have a diameter, that makes this arc a semicircle, which is 180 degrees. And these points where they intercept, right, make this an inscribed angle, which is half that measure, so it's 90 degrees. What I like about this is it doesn't matter where I draw, where point D is along this half of the circle, it will always make a right angle. I made point D right here. That would also be a right angle. Right? If I made it way over here, it would always be a right angle. It doesn't matter where it's at. It's always going to be a right angle because it's a inscribed angle that has an intercept at the 2 points where the diameter. All right. Here's our relationship we've talked that I was talking about a couple minutes ago. We have a central angle that's 98 degrees, right? And we need to know what the arc measure is, AB, and what the inscribed angle, ACB, measure is. Right? Well, we know that the central angle is equal to the arc degree measure. So arc AB is 98 degrees. And we know the central angle is half of that measure. This is 49 degrees. Okay. Now you could skip ahead and you could talk and say that when you have a central angle and an inscribed angle, and they have intercepts at the same 2 points, the inscribed angle is always half the measure of the central angle. Or the central angle is always double the inscribed angle. And again, it doesn't matter how we draw this inscribed angle. I could draw it way up here. Okay. It's still going to be 49 degrees. And it's all based on that arc measure. Okay. It's all based on that arc measure. In this case, 98 degrees. It's inscribed, therefore making it half that measure. I will share these slides with you guys, so you don't have a chance to copy it all down. All right, here we've got a little zigzag going through a circle. We're given a couple arc measurements, and we're also given one inscribed angle measurement. And we need to figure out what angle DCB is. So figure out that. Then figure out arc CA. That out, and we need to figure out what arc DC equals. All right, let's do these one at a time. I'm going to do angle DCB. So this is an inscribed angle. It's half of the arc measurement, so it's half of 56. I believe it makes that 28 degrees. Okay. Arc CA. This arc, the inscribed angle is 43. which is half the measure of this, so I have to double that. 86 degrees. And lastly, to find arc DC. Arc DC is not, we don't have an inscribed angle or central angle to work off of, but we do know what the other three arcs are of our circle. So if we take 360 and subtract those three measurements, we get 88 degrees. And again, we just need to know that that makes up all 360 degrees of our circle. A lot of times we'll have not just angles inscribed, but those inscribed pieces all fit together to make a quadrilateral in this case. Now we can use some of these properties to find these missing pieces. All right. Now we do know that opposite, if you do have a quadrilateral inscribed within a circle, the angles opposite one another. The angles opposite one another should be, in fact, so this should be 65. They should be supplementary. Okay, they should be supplementary because I know that this arc and this arc added together equal 360, and half, these two added together should be half of that 360, that should be 180. So if this is 65 and that's 115, that does make them supplementary. Now we can go through and find some of these different pieces, but we gotta kind of look at them one part at a time. They're asking for a lot of information here. I know that arc AC is going to be double 65, so that's going to make this 130. Arc CBA. Arc CBA, so CBA, and that's going to be 360 minus 130, so that makes it 27. Was that 230? Okay, arc AD. Well, if arc ADC, if this arc or arc AC equals 130, I can subtract 43 from that to get arc AD, which would be 87. Right. Let's see if I have enough information to do these other parts. I may want to go find these. That. Figured out that. We have enough for angle A. I want to say we don't have enough for any of the other parts. I remember there being one question like this on this, where they were kind of missing an angle. Does anybody see any other missing piece that I could put on here? Or not a missing piece. Does anybody see any other angle that I could find, whether it's arc or an angle?
If you find like a
If we were given that this was a kite, we could do that. But we're not given kite. Yes.
Wouldn't angle be a angle A pretty much 90 because E is a 1 off diameter.
So if this were a diameter,
Yeah.
I know it looks close. Because it's not drawn though, we can't assume that it is. If we were given that, then yes, that'd be a good one. That'd be very helpful. But we can't assume that it is. I think this is all we can do with this. I don't think there's any other angles we can find here. We would need one other piece And I think just one angle, either this angle, or even one of these two arc measures, right, would be enough for us to find the rest. Because if we knew what one of these two were, we'd be able to find the other one. Same thing with these two angles. If we knew what one of these angles was, we could use that to find the arc, which we would then use to get the fourth arc. But in this case, I don't think we have enough information to fill out these last four pieces. Now, on a test, we wouldn't leave a blank for you guys. We'd make sure you guys could complete the whole thing. All right, last part here, tangent lines. Okay. A tangent line is a line that touches the circle at exactly one point. A tangent line is treated exactly like an inscribed angle. Okay, it's treated exactly like an inscribed angle. So this arc from here to here is 268 degrees, right? This angle, just like an inscribed angle, is half of that arc measure. Okay. So this angle would be 134 degrees. Right. Now, not only that, but we can use this fact to find A, right, which is 180 minus 134, so that'd be 46 degrees. Then we could either use that to find my new arc measure, or we could do 360 minus 268 to get arc AB. Probably the easiest way is just do 360 minus 268. Is that 92 degrees? Yeah. 92 degrees. Okay. So treat your hinge lines just like you would an inscribed angle. And really it makes sense because it's an angle with a vertex on the circle. Right? It just doesn't intersect at 2 points. The intersection points are at the vertex and the other point. Okay? But again, treat it just like an inscribed angle. Again, I will share these notes with you guys so you'll have access to them. I'm also sharing the assignment with you guys. All right, it has been posted to Google Classroom. There are 15 questions. And I will share these notes. I'll share these notes with right there in the assignment. So you guys will have access to it.